Hello everyone, let us now learn about tides. Now the question is, why do we have to learn about tides when the elevation of the underwater features, say for example, if we're doing a hydrographic survey, will remain the same because the reference is constant. Okay, the mean sea level, for example. So based on experience, it is important to learn about tides because it is crucial in the planning stage of a particular survey. And also if you're doing research, say for example, research on flooding, then the tidal information is a very crucial input to that research problem. Okay, so let us now review how tides actually occur. So if you are standing on shore, so let's draw, let's say the sand is white because you are in Boracay. And then we have here water level. So this is the time when this is ebb tide or hunas in Bisaya. And then this is flood tide or taob in Bisaya. Okay, so it is easy to perceive the tides as the rising or falling of the water level or a horizontal movement moving towards the shore and moving away from the shore. But how do tides actually occur? So it is common knowledge that it occurs because of the gravitational attraction between the Earth and the Moon. So it is also used in many jokes. So they say the gravity of the Moon sampak to the Earth. So this is actually the case for tides. So due to this attraction, the water surface right here, there's a bulge in the water surface right here due to this gravitational attraction. Okay, so we have here gravitational attraction between the Moon and the Earth. And then on the opposite side of the Earth, there is actually another bulge, but it's not equal in magnitude. It's actually a little bit, the rise in water level here is a little bit smaller compared to the rise here, closer to the Moon. And this is caused by the centrifugal force because of the, from the center of gravity due to the attraction of the Earth and the Moon. Okay, so this is actually how tides are formed. So, for example, the Earth rotates as it continues to rotate. If you are here, then this is a low tide, and if you are here, definitely a high tide. If you are here, then this is a low tide again, and here, this is a high tide and then low tide. Okay, so this is actually mind blowing if this is the first time that you learned about this. It's really cool. So let us now proceed to some definition of terms. Okay, so we have here the definition of a tide. It is the half-day cycle of rhythmic rise and fall of the surface of bodies of water due to the gravitational attraction of the sun and the moon and the rotating earth. And tidal current, the horizontal movement of water accompanying tides. The flood tide is the taob, water surface rising and moving towards the shore. In the ebb tide, water surface is falling and moving seaward. Then slack water is basically the transition between the flood tide and ebb tide and vice versa, where the tidal current is changing direction and flows either in or out. And set and drift is direction and speed of current flow. High water is the max height of water above a standard datum plane in a given period. And low water, the greatest depression of water surface below standard datum in a given period. Then the tide range is the difference between the high and low tide at a location on a given date. The tidal day, idealized average period of 24 hours and 50 minutes between the occurrence of successive high tides of the same type and location. We have here stand. Stand of the tide is the period around which the greatest peak or depression of the tide is reached and during which the changes in height of the tide is scarcely noticeable. And finally, we have tidal waves, a large head or front of water generated at the surface of the ocean. So if you see this, then you better run for your life. Now there are actually different types of tides. So we have here diurnal, semi-diurnal, and mixed semi-diurnal. So a diurnal tide cycle is an area has a diurnal tide cycle if it is if it experiences one high and one low tide every lunar day. And for semi-diurnal, if it experiences two high and two low tides of approximately equal size every lunar day. And for the mixed semi-diurnal cycle, you have here an area experiences two high and two low tides at different size every lunar day. So you can see it in the diagrams here. So the semi-diurnal has the magnitudes are equal. Now the pattern for the mixed semi-diurnal and the semi-diurnal are the same, but the only difference is their magnitudes, as you can see right here. And this also. Okay. Now there's also what we call the neap tide and also the spring tide. So let's go back to our figure. Okay, let's draw another representation here. So we have here the Earth and the Moon. So we have here the major on the left and the figure that we just draw before. So the Moon has the greatest influence on the tides. But actually the Sun also has a tidal influence. So let's say we have here, this is the influence of the Sun, right? So it's actually bulging still on the sides. Okay. Now, if the Moon is in this position right here, as we all know, the Moon rotates around the Earth, and it completes one rotation every 27.3 days. So it actually moves from here to here, here. Okay. So if the Moon is right here, so we have the effect is the same with our previous drawing. So let's just exaggerate it a bit. So this is what we call a spring tide. Okay, this is a spring tide. And then, however, if the Moon is right here in this position, then the bulge will take place here also. Okay, so this is what we call a neap tide. Okay, this is a neap tide. Okay, so now we know the difference between a spring tide and a neap tide. Okay, so back to the semi-diurnal, diurnal, and mixed semi-diurnal patterns. There are different parts of the world experience different patterns. So if we take a look at the far left here, this is the location of the Philippines. We have a mixed semi-diurnal tides on the eastern side of the Philippines and a diurnal pattern on the western side of the Philippines. It's good to know. We also have specific tide levels used as surface of reference for depth measurements in sea and as a base for the determination of elevation on land. So we have the mean lower low water, mean low water, mean sea level, mean high water, mean higher high water. Now you might be wondering, why not just use one, the mean sea level, right? So there are different applications for these different references. Let's say, for example, the mean higher high water. This is used particularly for nautical clearance. Let's say, for example, if you are designing a bridge, you want to make sure that in that particular bridge, the boats that are passing underneath the bridge have the safe clearance no matter what the tide is, right? So it is beneficial to use the mean higher high water tidal reference. Okay, so they have different applications. We also have tidal benchmark. It is a fixed vertical monument used to reference a local tidal datum. So this is an example of a benchmark. So how these are established? These are established using tidal observations. So you observe the tide for a period of time, significant period of time, and then you then get the average of that, and you will get the mean sea level. Then to facilitate the process of establishing tidal datums, tidal stations are operated at various locations. So this is a tidal station where tidal observations are made for a certain period. Okay, so that's basically it for tides. And we will proceed in the next videos with the processes in determining soundings and locating positions when taking soundings. Okay, so thank you for watching, and I will see you in the next videos.